By now you should have a pretty good idea of what the word congruent means. Congruent means that things are both the same size and the same shape. They're actually copies of each other. And so if I took this quadrilateral over here and I named it, the notation for this, since it's a quadrilateral, I can actually just draw some force-shaped-sided figure and then write the letters after it. Now, if I were to take a copy of that, now I could take this shape and I could rotate it around in any direction, and it's not going to change its size or its shape. So I'm going to leave it because I think it's a little easier to kind of comprehend if I leave it in the same orientation. But I'm going to rename all of these vertices. I'm going to rename them with these little markings here. And what these are saying is that each one of these is the first image of its corresponding letter, meaning that they're all related. In this case, I did what's called a translation, which really just means that I moved it. That now I know that all of these correspond with each other. And I'm going to show you the notation now. All right, now let's talk about this notation. This notation is actually super powerful. Remember, if they're the same, or if they're congruent, they have the same size and the same shape. So everything about them is exactly the same. So what we're doing here is by putting the A first, we're saying that the angle that's at vertex A is congruent to the angle that's at vertex A prime. And the same thing for all of them. Angle B is congruent to angle B prime. Put 2 markings there, and so on. And all of that information was just gotten from the order of these. So whatever vertice is first in each one of them, those are called corresponding. But those are corresponding, again, in this case, angles, but there can be corresponding other pieces as well. So let's go ahead and look at the first 2 pieces here. So AB, segment AB, well, that's the first 2 letters. The first 2 letters here are segments A prime, B prime, and those are also going to be congruent in this case. And we can go right down the line and do that for every single piece of this. BC is congruent to B prime, C prime. CD is congruent to C prime, D prime. And lastly, this one's a little harder to notate, but if we go from D and kind of jump back around to there, we get that AD is congruent to, and we do the same thing here, A prime, D prime. The way I set up these letters, this is really obvious. I did that on purpose because I thought it would be more clear. It won't always be the case, but if you're naming the vertices, you can see how this notation makes it really easy to identify, well, what is A corresponding to? Well, it's corresponding to A prime. What is C corresponding to? It's corresponding to C prime. And having everything in order makes it really easy to read this notation. But I just wanted to point out in this how powerful the notation is. And you have to keep in mind that whether you think that this is that worthwhile or not, the order that you write these matters. And that's kind of the idea of this common language, in that if we all understand that we're going to do this every time, then other people can read your work without having to talk to you, and your work speaks for itself.